Hi everyone. Today I have a special program for everybody because I'm participating in a program called Mythbusters. Mythbusters is a Discovery Channel program where, as the name suggests, a group of scientists take on various myths to prove whether they're true or false. And today I'll be doing the same. And so I've received这个盲盒 and now I'll open it and find out what myth it is that we are going to bust today. 好，这是我的说明书。我们邀请你接受留言终结挑战，并为你准备了一份抛砖引玉的实验包。好，这是我们的 myth， 就是一张纸能不能对折7次以上 ？So, can you fold a piece of paper more than 7 times? I actually know the answer to this one. The answer is, it is possible, but it's super difficult. But let's give it a go ourselves and then explain some of the science behind why 7 is such a hard number to surpass. So, what I have in here is a bunch of different types of paper. We'll try different thicknesses, different sizes, and see whether that makes things easier or harder. Now, with folding paper, you can imagine there are 2 major variables. One is the kind of size, width, length of it. And so here we have ordinary A4, slightly larger, and then 海报的那张纸. So we can see how important the width is to the folding. Then of course we have thin stuff like napkins and toilet paper, and we'll see how the thickness determines how much we can fold. So to begin with, let's just try the ordinary paper. So let's start folding. 1, 2, 3, 4. So we're getting a bit harder. 5, 6, and I do not have the strength to do 7, so 6. 6 is what we can get using ordinary A4, so the myth is still intact. Let's try the biggest piece of paper here, see if that makes any difference. It's got a bit creased in transit, but since we're folding it, I don't think it makes any difference. Okay, here we go. Before I do this, think to yourselves, do you think that the overall size of the paper should make a difference here? Or do you think that the answer is independent of the width? Okay, here we are. 4, 5. You can see we're approaching the familiar 7. Let's try our best to do 7 on this. Oh yeah, just about, maybe. 7. But I'm not even going to bother trying 8. I'm not even going to bother trying 8 with this. As you can see, 8 is just not going to happen, no matter how much I push. So that's ordinary paper. 7 appears to be the maximum, although I'll tell you what the Guinness World Record is after I've tried thinner pieces of paper. Here we are. This is about as thin as we can get. So maybe the thinness will help us. Let's start again, shall we? Fold 1, fold 2, 3, 4, running out of space here, 6, and again. Can't get to 7. Kind of 7, but I think we can all agree that we're not going to get an 8th out of that. Let's tear off some of this, a slightly longer piece, because it looks like we ran a little bit out of mileage there, and see whether that makes a difference. Now, if I unroll this entire roll of tissue paper, I could probably achieve 7 or maybe even 8. In fact, the Guinness World Record is at 12 times, achieved by a high school student in the US, who I believe used a roll of paper that was 1,200 meters in length. So the length does make a difference, as does the thickness. But you can see, I'm not about to unroll and waste an entire tissue roll to show you that I can do 7 folds or even 8 folds. Maybe we should try that actually. So let's try something a little bit more extreme. Let's see if we can at least get to 7. Okay, this is probably about as much as I can practically manage. Okay, my dog's chewing on the end of it, so let's see how that affects the experiment. Fold number 1. Okay. Fold number 2. Okay, boys. Fold number 3. Looking promising. 4. 5. The dogs like tissue paper. Here we go. You want to fold the paper as well? You want to fold the paper as well? No? 6. 7. And there isn't going to be an 8th. So, it seems that 7 does appear to be the maximum, or at least the maximum that I can achieve in my own home without wasting too much paper. But let's consider what actually is going on here. What's the interesting science about why paper is so difficult to fold? Well, it's a very simple equation. Every time you fold, you double the thickness. So if our beginning thickness is W, after n number of folds, we have a width of W times 2 to the power n. And it's this thing here that's causing us the problems, because this makes the whole thing exponential growth. In other words, the width with number of folds is going to look like this. And very quickly, you start getting extremely thick pieces of paper, even for relatively low n. By the time you get to 7 folds, you're multiplying the width by 2 to the 7, which is 128. When we get to 12 folds, that's the high school student's record, you're at 4,096 times the original width. By the time you get to 30 folds, if you have an ordinary piece of A4 paper, which is around 0.1 millimeters in thickness, you will achieve a paper stack of 100 kilometers in height, which actually is enough to technically put you into outer space. 42 folds will get you to the moon. I believe 81 folds and you're already at the width of the Andromeda Galaxy. At 103 folds, you're outside the length of the observable universe, 93 billion light years in length. So you can see from 103 folds, you're already getting to something that's larger than the observable universe. This is the beauty of exponential numbers, the power of the exponent.